All right, hello everyone. This is our next video for Unit 2, Lessons 21 and 22. In our last video, we looked at how to examine some simple situations involving rational functions. So for the next couple bits, we will look at how we can write equations with some really specialized rational functions in different situations to answer a few different problems. And really, here the focus will be on solving equations. All right, let's get started. A little bit of a warm up here where we have to solve some equations. All right, let's see. X over 2 equals 3/4. Oh, okay. Mentally, huh? Well, this sounds like a proportion problem. We can either solve it like a proportion or we can think like equivalent fractions. Let's see. So x over 2, 3/4. So to get from 4 to 2, I divide by 2. So looks like this is going to be x equals 1.5. Okay. Same thing for some of these. So 3 goes to 1. So, or if we look at it this way, 1 goes to 3. We multiply by 3. So x must be 18. Okay. Ooh, 1 over 4 equals 1 over x squared. Well, wouldn't that just mean that x squared is equal to 4? Okay, so what numbers would that work for? Well, x equals 2. Oh, but don't forget that x could also equal negative 2 in this case, because negative 2 squared does give you 4. And what about the bottom one? 2 over x equals x over 8. Ooh, okay. So this is one where, if you can't figure it out right away, then perhaps you can solve it like a proportion. So how do we solve a proportion? Remember, we can cross multiply. So what we have is we have 8 times 2 is 16. And we have 16 equals x squared. And so x can equal 4 or negative 4. All right, sounds good there. So our main um, theme for the next couple lessons is going to be on cross multiplying and proportion questions. So let's see how that comes into play. We have a rational river. Noah likes to go for boat rides along a river with his family. In still water, the boat travels about 8 kilometers per hour. Okay, so a little fast there. In the river, it takes them the same amount of time t to go upstream 5 kilometers as it does to travel downstream 10 kilometers. Huh, okay. So, how does that work? Well, don't forget that the river is moving. And because the river is moving, when you go upstream, you're going against the river, right? So you're going slower. And when you go downstream, you're traveling faster. So when you travel faster, you can go farther, right? That's the idea. Okay, if the speed of the river is r, write an expression for the time it takes to travel 5 kilometers upstream and same for 10 kilometers downstream. Ooh, how do we do that one? Okay, so an expression for the time it takes to travel 5 kilometers upstream. All right, so we need some sort of relationship here. So we're solving for time, and 5 kilometers, that sounds like a distance. And we have a rate, don't we? We have a rate the boat travels. So this sounds like it's a situation where we need our good old friend d equals rate times time. However, we're writing an expression for the time it takes. So shouldn't we solve this equation for t? Well, let's do that. Let's divide by r. And so we have t equals distance divided by r. Or we can say distance times rate, because we're going to have to use r, it looks like, down here. Okay, so write an expression for the time it takes to travel 5 kilometers upstream. So that means d is 5, so t equals 5 over. Now we're traveling upstream, right? So remember, the boat travels at 8 kilometers per hour, so the rate should be 8. However, don't forget that because we're traveling upstream means the river is going to be pushing against us. So in this particular case, let's say here's my stream. Let's draw it up here. Here's my stream. Okay. So when I'm traveling upstream, here's my boat, and I'm traveling at a rate of 8. Now, my river is going back at us again, and how fast is the river going? Well, it tells us r. So let's use r. So what's the overall speed that's going to happen? Well, you're traveling forward 8, but the river is pushing on you by r. And when it's pushing on you by r, it's slowing you down, right? So we're going to do 8 minus r. And that's going to represent the first bit when we're traveling upstream. So let's do the same thing when we're traveling downstream. So for when we're traveling downstream, t equals 10 for the, now we're doing this 8, we're traveling 10 kilometers. But now what's my speed when I'm traveling downstream? So downstream, we're going to reverse this, right? Now, instead of the r going this way, let's say we're going the same direction now as the river. So now the river's not pushing against you. The river is pushing behind you, and it's kind of helping you travel forward, right? And so it's going to help you travel faster. So if you're traveling 8 and the river's adding r to that, we're going to have 8 plus r here. So when we're traveling upstream, downstream, but it says that the same amount of time t. And notice there I use t for both of these. So if both of them equal t, what do you know about these expressions? Well, if they both equal the same thing, then they themselves are equal as well. So I can now write the expression, let's use a different color, 5 over 8 minus r equals 10 over 8 plus r. Okay, so last time in class, when we solved equations where we had variables in the denominator, the biggest thing that I told you was just, well, multiply by the denominator, right? Get rid of the fraction. We have a problem here. We have two different denominators. So what do we do? I mean, I suppose you could multiply by both denominators, but that would get messy. So instead, looks like a proportion question, doesn't it? We're going to cross multiply, and that's going to make this problem so much easier. Because when I cross multiply, okay, so I'll circle that. Remember when you used to do this like in middle school? I end up with the following equation. 5 times 8 plus r is equal to 10 times 8 minus r. I think we could solve that equation. That's an Algebra 1 equation. 40 plus 5r equals 80 minus 10r. Excellent. Now, all we have to do is just keep going that. We're gonna, let's see, what should we do here? How about we subtract the 40 from both sides? And so we have 5r equals 40 minus 10r. Add the 10 to both sides. So we have 15r equals 40, and we divide by 15, and we get r equals 40 divided by 15, which is going to be 3.6 repeated kilometers per hour. So that's how fast the river is going. So about 3.6. Um, so that's kind of interesting when you look at that way. And when I think about it, I'm trying to put these numbers together. So 8 plus r is going to be 11.6. And then 8 minus r is going to be 4. All right. No, I think we're good. I just want to make sure that my math here is in fact correct. And I believe that it is. Okay. Yep. Distance over. So it looks like 3.6 kilometers per hour. All right. Oh, wait. It looks like I made a little tiny mistake here. Whoops. That's not 3.6. That's 2.6. Let's erase that a little bit there. And let's make that change. So a little bit of a math error there. 40 divided by 15. Um, maybe what I should do is double check this in the calculator. Where's my calculator? There it is. And boop, there we go. And calculator, 40 divided by 15, 2.6. Yep. Yeah, I made a little mistake there. Okay, perfect. So, good now. All right. The idea behind this, outside of creating the expression, is that we can solve these sort of rational equations pretty easily by using some cross multiplying. So, that's going to be our theme. Let's continue. All right. So, show that 2 over 4 minus x equals 10 over 4 plus x. That equation is equivalent to 12x equals 32. Okay. So the rest of it, though, let's ignore the rest of it for now, and let's just show this part. Let's just start here. So let's take a look at this equation. So if I take this equation, remember what I can do here is I can cross multiply now. Okay, so I'm just gonna cross multiply, and so what I have is I have 2 times 4 plus x is equal to 10 times 4 minus x. Okay, so let's go ahead and simplify that. I get 8 plus 2x equals 40 minus 10x, right? A little bit of distribution there. Okay, now let's simplify. Maybe I'll add 10x to both sides. So plus 10, plus 10. So just always remember to add your like terms and subtract your like terms as necessary. So we get 8 plus 12x equals 40. I can subtract 8 from both sides. 12x equals 32. Okay, wonderful. Hey, look, when we solve the equation, we got this, 12x equals 32. Now, when we solve that, we can, again, it's a decimal. Interestingly enough, we get the same answer we did before, about 2.6 repeated. Yeah, about 2. Yeah, we got the same answer, 2.6 repeating. Interesting, but that part's not really necessary. Let's look at the second part here. It also then happens to say, for all values of x not equal to 4 or negative 4, Why would it say that? The reason why it says this is because look at the original expression. The original expression um, says that we have a 4 minus x and a 4 plus x in the denominator. So what happens with these? These are vertical asymptotes. And so in this particular case, these produce 0 in the denominator. These produce 0 in a denominator. The 4 produces a 0 here. The negative 4 produces a 0 here. So it doesn't matter which one. You get a 0 in one of them. So this expression is equivalent to this, except for here. And so you may wonder to yourself, well, you may be thinking, well, can I plug for it? But isn't the value of x, the value of x is equal to what? 2.6 repeated again? So then this is irrelevant, right? No. This has nothing to do with this part. It's not the particular value of x that's working for, okay? This is what happens when I plug different values in for x, right? So if I plug in a different value in for x, right? So like if I plug in a number like 10 or 20 or 30, I'll get a relationship here. I'll get a similar relationship here. But the problem is, as soon as you get 4 and negative 4, right? If I try plugging those in for x, this is unsolvable. So I do take it back. I guess this is related here. So because x is equal to 2.6 repeated, right? The problem is, what happens if I solve this equation and I get 4 or negative 4? The problem is, this equation has a solution, right? However, sometimes what's going to happen is this equation and this one, they are the equivalent expressions, except that this here cannot be done when x is 4 or negative 4. However, there are cases where this one could be. So we want to keep that in mind. But the thing is, because we get x equal 2.6 repeated, we're not going to have to worry too much about it. So again, so be careful that any values that we get as answers where we get zeros in the denominator, we can't trust those solutions. We won't be able to use them. All right, let's try a few problems. Diego went rafting all day with his friends. At the end of the day, his dad asked how fast the river was flowing. Diego knew that they were able to travel 6 miles downstream in the same amount of time it took them to travel 4 miles upstream, and their boat was traveling about 10 miles per hour. Okay, let's write an equation. So here's the thing, folks. The reality is there's a very specific kind of word problem here called the upstream downstream problem. And the formulation of it will be the same as we did earlier. So in the same amount of time. So we are going to use the same relationship, time equals distance over rate, okay? So he was able to travel 6 miles downstream in the same amount of time it takes them to travel 4 miles upstream. So downstream, 6 miles, 6 miles, right? So 6 over, now the boat's traveling 10 miles per hour, so my rate is 10, but we're traveling downstream. So what happens? We go faster. And when we go upstream, we're traveling 4 miles, and we're going upstream, so we're going slower. So we subtract that rate. So a good way to kind of remember how this works is you're given two sort of mileages. Um, the mileage downstream will always be higher than the mileage upstream because you're going faster. So the bigger number will be over the rate plus r, and the smaller number will be over the rate minus r. And then all we have to do is solve it. Okay? So here we could just simply cross multiply. And we just do pew, pew. And so we get 6, 10 minus r equals 4, 10 plus r. 60 minus 6r equals 40 plus 4r. And same thing before. We're going to subtract the 40 from both sides. And while we're at it, let's add 6r to both sides. And what I'm going to end up with is 20 equals 10r 2 miles per hour. And if you want, you can go and plug it back in and show that it works. So if you do, what you're going to end up with to check your work, you're going to end up with 6 over 10 plus 2 is 12 equals 4 over 10 minus 2, 8. 6 over 12, 4 over 8, check mark. We're good. And that's how the river problems work, folks. Okay, so here's a summary of exactly the same kind of problem. So again, here's another kind of example of the upstream downstream problem. The formulations are all going to be the same. There is not much that we can do to change this. It's a good problem, right? Figuring out the river speed based on your effect of going upstream downstream. This is a really good real life problem. But one of the issues is if we start trying to put in extra information, we will have an equation that's a lot more difficult to solve, and we'll have to use different analytical techniques. So the good news for you guys is these equations can't really deviate without becoming a major hassle. So as long as you can solve these equations of this way using some cross multiply, we're going to be fine. Okay, guys? All right. Let's go on to lesson 22 now. So lesson 22 is a little bit more of the same, but a little bit deeper into the whole cross multiply part. Again, we're not going to do anything fancy or new other than the cross multiply. Everything that you're going to see is stuff that you've already done. Okay, so let's look over the work. So here's another type of proportion question, right? Okay, so let's see what's happening here. 3 over x equals 2x plus 1 over x minus 1. Ooh, 3 x's. Yeah, more and more x's every day. So, all right. Cross multiply? Check. So let's write that down. Cross multiply is good. Excellent. What happens here? Distribution. Looks good there. Oh, but now we have an interesting thing happen. We have an x squared term because we did 2x times x, and that gets me 2x squared. Huh, what do I do with this? Well, the problem now is we can't just collect the terms, divide, and solve, right? Because we have an x squared term, we now have a quadratic. When we get a quadratic, now we have to start thinking about all the quadratic things we did. Factoring and those sorts of things, square roots maybe. So our mind is really actually going to kind of jump to the whole factoring piece. And that's going to kind of come next. So we're going to be looking at how to work some of those tools into here. Okay, so now we collect all the terms to one side. Okay. Um, so we do this. We have 2x squared minus 2x plus 3. And again, we know to do this because we can't do anything with the x squared. So we won't be able to split this and solve it. So 2x squared minus 2x plus 3, we have really two options. We can factor it, or we can do completing the square. So factor, or now I said completing the square, but would completing the square it'd probably be a mess on this one. So maybe quadratic formula instead. I was thinking quadratic formula, but then said completing the square. Oh well. Okay, so factor or quadratic formula. Now I'm thinking about this and I'm looking at this expression. 6, negative 4. This one doesn't factor. You can't divide out the 2. And I'm trying to go through pairs of like the 3 and the 1 and the 2x and the x, and I'm just not seeing it here. So I think quadratic formula is going to be the way to go. So here's one where you end up with a bit of a mess. And so remember what I said before with the last lesson is if we try deviating into questions like this based on like some other fancy stuff with these word problems, we do end up with a little bit of a hassle. Now, could we solve this? Sure. It's just all we had done is a few extra steps of cross multiply first. Okay, but we're not going to actually solve it here. If you want to go ahead and solve it, you can. But you will get some answers involving square roots. Okay, so let's actually try solving some equations. By the way, as a side note, I hope I don't sound too nasally when I do this. I am recovering from a cold. But hey, we all do that, right? Okay. Solve the rational equations. Think about the best possible method for solving each one. Okay. So the way that these work is we'll start with the cross multiply like we normally would. But what's going to happen is we'll end up with a quadratic. And so we're going to have to reach back to the last unit and really kind of see how we can solve that equation. So let's see what happens. Let's start with some cross multiply. By the way, one of the reasons that we know this has happened is because we have x's in 3 different spots. So we get x times x plus 6 equals negative 1 times x plus 10. Okay, so x squared plus 6x equals negative x plus, no, minus 10. Oops. Boop. Let's do minus 10. Okay. Now, because we have the x squared term, rather than try to like combine like terms or anything like that, instead of trying to put them, balance them, let's bring them over all to one side. So I'm going to add the x to both sides. And then I'm going to also add 10 to both sides. And so what I'm going to get is x squared plus 7x plus 10 equals 0. Remember that with quadratics, you want the equations to equal 0 so that you can apply the zero product property. Okay, so next order of business. Can we factor it? And if so, do it. And then if that doesn't work, then you'll have to rely on the quadratic formula. Okay, factor. Let's try it. What does x squared break into? X and x. What numbers multiplied give you 10? Okay, so 10 times 1, 5 times 2, 5 and 2. Now the thing about 5 and 2 is they add to give you 7. So remember that when you look for the factors of 10, you have to find the factors of this number, the 10, that add to that middle number. So plus 5 and plus 2. So remember our work here, x equals -5, x equals -2. And so either one of those answers are going to work in this expression. So that's another thing to keep in mind, is that sometimes we do end up with those sorts of, multiple answers. And when you do this out, you will find that, in fact, it works quite nicely with either number. Okay, how about the next one? Let's go back to blue. Uh, let's cross multiply. So 1 times this, all right, so we have x times x minus 1 equals 1 times x minus 2. We don't have to put the ones because they're ones. X squared minus x equals x minus 2. Perfect, all right. We have an x squared term, so let's collect all the terms on one side. So what I'm going to do is I'm going to subtract. Let me just make sure I got it here. Okay, I'm going to subtract an x from both sides. Because the x squared's here, I'm going to subtract x and add 2. And I got x squared minus 2x plus 2 equals 0. Okay, can I factor this? 2 times 1 is not going to give us anything close to this. So it doesn't factor. We'll have to use the quadratic formula. All right, I wasn't going to do this before, but let's just go ahead and do it now. Okay, so x equals opposite b plus or minus square root c all over 2a. Okay, so let's do it out, right? B is -2, so we get 2 plus or minus square root b squared, so that's 4, minus 4 times 1 times 2. Okay, I'm looking at this. Ooh, this is gonna be... Oh boy. 4 minus 8 is -4. Oh, that's all kinds of ew. Can't have a negative under the radical. Okay. Let me make sure I did this problem right, because that doesn't seem... That seems kind of unexpected. Would have thought there'd be a number that works here. Not 1, 2, maybe -2. No, not -2. Yeah. Yeah, so it doesn't look like there's one that works. I'm trying to just think, but looks like we did fine here. We got x squared, we got a minus x. All that works. We added 2 to both sides. We subtracted x. Okay, looks like we're good. This one has no solution. Well, that's okay. That sometimes happens. Well, we roll with it. Okay, next one. Jada is working to find values of x that make this equation true. Okay. If I multiply both sides by x times x plus 1, I find that my solutions are x equals 1 and x equals -1. Okay, so Jada uses a unique way of doing this. So remember that there's 2 ways that we can solve problems like this. The first way is to cross multiply. which I find to be the easier way of doing things. However, I did mention briefly earlier that one other technique that we can do, and that actually we had started with in class, was to just multiply by all the denominators. Um, and so that's actually what Jada does here. We're going to kind of, you could try that if you want, uh, but we're going to say that cross multiply is just as good a technique as that. So let's actually see what happens when we do that. We get x times 5x plus 5 equals 5 times x plus 1. 5x squared plus 5x equals 5x plus 5. Okay. All right, so let's subtract. All right, so here's an interesting situation. We have all these 5's in the equation. Now, look at this. There's a 5x on both sides. That's interesting because what that means is I can subtract the 5x and it disappears. So what I have is I have the equation 5x squared equals 5. Now, lovely for us, we don't have to factor that. We don't have to do quadratic formula unless you want to, but like it'll be hard to do on this. Instead, we divide by 5, and I get x squared equals 1. Well, what times what equals 1? X equals 1 or x equals negative 1. So Jada is correct. Those are indeed the solutions to this expression. And, if we plug 1 in for x, we certainly get that, right? If we plug 1 in for x, we get 10 over 2 equals 5 over 1. Okay, perfect. So when I plug in 1, that one works because I'll get 10 over 2 equals 5 over 1. Okay, what about negative 1? So let's try plugging negative 1 in for x to check our work, right? So we get 5 times negative 1 plus 5 over negative 1 plus 1 equals 5 over negative 1. Okay, so what we end up with is the expression now with negative 5 plus 5 is 0. We end up with 0 over 0 equals 5 over negative 1. Huh. Well, is that true? Um, uh, okay, that's different. What is 0 divided by 0? Well, I know we can't divide something into 0 pieces, right? Okay, so remember that we know the reason why we can't divide by 0. Like if I have like 3 and I can't divide it by 0, why can't I divide it into 0 pieces? Because I already have 3 things, right? But what if I have nothing to begin with and then I divide them into pieces of size 0? Or divide them into 0 pieces? In that case, I have no pieces. So how many pieces do I actually have? Do I have 0? Or do I have something else? This is nonsense. 0 over 0 is a very special number-ish called an indeterminate number because we can't really process what that thing actually means. So we're just going to call it nonsense for now. That doesn't really help solve the equation. So what that means in this particular case is that negative 1 must be rejected. And so my only solution to this expression is x equals 1. So one thing to keep in mind, guys, okay? Yes, we took the square root here of 1, and yes, 1 times 1 is 1. So I don't want you to think that, oh, just drop the negative 1. The negative 1 does weird things. It's not necessarily that one. It could very well have been, with a modification, that negative 1 works and positive 1 does not. If I change those signs from positive plus to minus in the original expression, then 1 would have been rejected, not negative 1. So what you're going to want to do for a rational expression is when you get answers, you want to check them to make sure that you don't get a case like this. And that's easy to check because when you look at this, you might be able to tell right away that negative 1 makes one of the denominators equal to 0. So it ends up being a vertical asymptote. So any numbers that are vertical asymptotes or that make the denominator equal to 0, they are not going to be able to solve the problem, even if the math points in that direction. So even though we were able to get a negative 1 out of the expression, it's not going to work because of the x plus 1. So why does Jada's method produce a value that does not solve the equation? This is really why. You get a 0 over 0, which is nonsense. Okay, so moral of the story, check your work and see if all the values actually do produce answers. This is what we call an extraneous solution. It's a solution that comes from the process of solving an equation, but it is not a valid solution to the original problem. Another place where this has come up in the past is when we solve a quadratic motion problem and we ended up getting negative time. Remember that happened a couple times where we would solve, like, how long does it take for the object to hit the ground? But one of the answers came out negative. Same idea here. We were able to eliminate an answer that didn't make sense. But here, the reason why it doesn't make sense is because of a vertical asymptote. Extraneous solutions occur when multiplying or dividing by a variable. And because what happens is if that through that multiplying and dividing, you happen to be potentially multiplying or dividing by 0, it does introduce a bit of error into the work. And it introduces a division by 0 into the solving. So it creates the kind of like this false solution. So ultimately, like I said before, look to see if a solution produces a 0 in a denominator, because if it does, then we can't use it. Okay, here are a lot of equations. Now, am I going to solve all of them in this video? No. However, get a chance to see what your extraneous answers could be. So remember what I said before. Look for vertical asymptotes. So you know right away that those answers are not going to work. So for example, for A, right? If you look at A, you have a denominator with an x minus 2. So when we go and actually solve this equation, no matter what answers of x that we get, fractions, decimals, whatever, I don't even know what answer we're going to get. Whole numbers could be anything, right? Except that x cannot be 2. And that's because it would create a 0 in the denominator. How about here? If I solve this equation, what answers would I get rid of? X can't be 2, clearly, but also X can't be 0 either. So my question here is, what can X not be? How about here? X plus 8, X minus 8. So it looks like X cannot be 8 or negative 8. And so on and so forth. For this one, X can't be 1. Get the idea? Ooh, what about this one? X can't be 0. What about negative 1? X can't be negative 1 either. X can't be 0. X can't be 2. And so we just keep going. X can't be 0 or 3. Now, in this case, it doesn't matter if the x minus 3 repeats itself, right? Doesn't matter how many times it occurs. If it can't have a 0 on one side, you can't have a 0 on any side. And finally, x cannot be equal to negative 1 for this one, no matter what happens in any other expression. Okay, that's kind of how it works. Okay, so real quick, we can just take a bit of time and let's solve these last couple rational expressions and see what happens. So remember, easiest way to do them is to cross multiply, but we're just going to make sure we do the final step of checking our answers to see if they work. Okay, let's cross multiply. X plus 2 times x minus 2 equals 3x. All right, so let's try it out. Now, how do you solve this? We want to collect all the terms on the one side, so we're going to have to multiply this out. We're going to get x squared plus 2x minus 2x minus 4 equals 3x. Ooh, cancels, cancels. X squared minus 4 equals 3x. Subtract 3x from both sides. Okay. So now we have that expression. Okay, it's a quadratic. So again, does it factor? If not, does a quadratic formula. Okay, does a factor. X and x, right? Because of the x squared. Negative 4. What multiplies give you negative 4? I got 2, negative 2. Nope. 4 and 1. Ooh, 4 and 1. How about x minus 4 and x plus 1? Because negative 4 plus 1 is negative 3. That must mean that x must be 4 or x equals negative 1. Okay, those are my answers to this problem. So now my last thing that I have to do is I'm going to go back to the original expression. And now I'm going to check. Do either of these answers make the denominators equal to 0? The answer is no. So therefore, we're good. None, neither are vertical asymptotes. And so we're good. If we got a 0 or a 2, that would have been a problem. But thankfully for us, didn't happen. Okay, cool. And finally, let's switch to red. Let's do the last one. I'll just do it on this side. So let's cross multiply. We get 3x times x plus 1 equals 4x, x minus 1. All right. 3x squared plus 3x equals 4x squared minus 4x. All right, let's combine some terms. Let's subtract 3x squared from both sides. Here we actually can do that because I have multiple copies of x squareds this time. So I can combine those terms together. And so I get 3x equals x squared minus 4x. Now I will add so now in this case, I will add the 4x to both sides, and I get 7x equals x squared. So what can happen here, right? Let's take a look. So actually, probably what I should have done is collected them all into one side, right? So actually what I should have done, let's go back here, is I should have subtracted 3x from both sides. And so that was probably a bit of a better thing to do. Yeah, can't get them all, right? We're going to subtract 3x. So now we have this. Now, does this factor? It most certainly does. We can factor out an x, right? We end up with that. So 0 equals x times x minus 7. So what can x be? X equals 0 or x equals 7. Both of those numbers should work. Let's start with the 7, right? So 7 we get 7 plus 1 is 8 over 28. And on this side, we would get 6 over 21. Yep, that totally works. So 7 works. But what about 0? Uh-oh, can't have 0 in the denominator, right? Because 4 times 0 is 0. Vertical asymptote. So as such, in this problem, we can't have 0. So my only solution to the problem is x equals 7. So, yeah, a little bit of work there, but not too bad if you made it through all our quadratic stuff. So nothing that we did is any different than things we've already done. We'll just have to make sure that we, consider factoring when we need to, okay? All right, folks. Sounds good there. Okay. So in essence, for the video to be not too terribly long, I think this should be enough to leave there. There's a few more equations that we can solve in class, but we have some good examples. And we can go through and take time and see if you can solve some of these just in case we haven't done it in class. Okay. Challenging problems, perhaps. Find the solutions to each rational equation. Identify if any of them are extraneous solutions. Ooh, challenge. You know what? Tell you what. Why don't we pick one and see if we can solve it? Ooh, some of these are good challenges though. Which one do we want to do? This could be interesting. That first one looks like it's going to be messy because you're going to multiply an x plus 1, an x plus 2, and an x plus 1. Do we want to tackle that one? Or the bottom one? The bottom one is going to have a harder expression of factor. Let's do the middle one. Let's see what's happening with that middle one. Okay, because I'm curious here. Oh, that middle one. Oh, you know what? That middle one is going to have this middle one's going to have, again, you're going to have an x to the third. Okay. Ooh, how about we do this? Let's do the first one. But I'm going to show you a shortcut because it says challenging problems perhaps. Okay. So if you've had a chance to toy around with these a little bit, that's why I kind of took a little bit of a pause there, is so that give you a chance to pause it and give it a try if you'd like. All right, there's a trick to doing this first one. Look at the fact that this denominator has an x plus 1. And then the one above it also has an x plus 1. Hey, when you have a fraction that has a common factor, can't you cancel out the common factor? Well, in this case, the common factor is an x plus 1. So what I can actually do is cross them out like this, because I have an x plus 1 on the top and an x plus 1 on the bottom. In much the same way that in some fractions, if you have like a factor of 5 on the top and bottom, you can cross them out. Same idea here. So what I actually now have is x plus 2 over 1 equals x plus 2 over x plus 1. And guess what? This is now a far easier equation to solve. And by doing this, this also has a very useful piece to doing that. It gets rid of extraneous solutions, and they're not hopefully going to pop up. So let's cross multiply. We get x plus 2 times x plus 1 equals x plus 2. Okay. Now watch what happens. Oh, wait a second. Now I have an x plus 2 on the left and an x plus 2 on the right. And they're factors in parentheses. Could I just cross them out? Can I divide both sides by x plus 2? Is that legal? Believe it or not, it is. So I'm going to do that. I'm going to divide by x plus 2 on both sides. And now I get x plus 1 equals 1. And that's an easy one to solve. Subtract 1, and x is 0. So if you go back to the original expression, is that really true? Does 1 work? I'm sorry, does 0 work? Well, let's try it out. You get 0, so you get 1. Let's check it. 1 times 2 divided by 1 equals 2 over 1. Yeah, it works. 0 is a solution. Fascinating. Okay. I thought I would do that one just to kind of see how some of this stuff works. The other two, give them a crack if you want. And if you're curious and want to talk about that in class, we can. But I'm going to warn you, those ones are not easy because they are going to involve some multiplying. They're going to involve some x to the third terms, and it's going to be kind of icky. I will warn you there. So do be careful. The bottom one, we'll just have a little bit of a harder factoring to it, okay? So here's my summary. So they solve it a little bit of a different way. We use cross multiplying, but their method is pretty much the same. And before, like, you cross multiply, simplify everything down, and then they're left with a quadratic that they were able to solve. Okay, so again, just keep in mind, guys, when you get to a situation like this, if you end up with extraneous solutions, just make sure that you discredit them. Okay, so some more things that you can read about it. All right, guys, but I think we're good here. We're at the last page, and here's the end of 2021 and 22. So when we're ready for a quiz, really just make sure that you can do your cross multiply, solve equations, and look for extraneous solutions. And those are the big skills that we learned here. Okay, guys, have yourself a lovely evening. Just about to hit the 1 hour mark, it looks like. So I think we did a pretty good job. Take care.